Hello guys, so today we are here to solve our daily LeetCode challenge for the day, and this challenge is construct K palindrome strings. Okay, this challenge is construct K palindrome strings. Okay, so in this, what is the challenge? The challenge is that we are given a string s and an integer k. Okay, we are given a string s and an integer k. Okay, we have to return true if we can use all the characters in S to construct K palindrome strings. So the key thing is that we have to use all the characters in S. Okay, we don't have to use only few characters. We can use few characters and leave the remaining. And can we construct K palindrome strings? So the number of strings, palindrome strings that we have to construct is K. So we should be able to construct K different palindrome strings using all the characters in S. So the total palindrome should be K, at least K, okay? And it should be using all the characters in the given string S. Okay, so this is the challenge, okay? So basically, if you take a look at these examples, then Annabelle is there and we have to create two palindromes. So Annabelle, this Anna is one palindrome, and then see in this B's after Anna, there is this Bell. So for Bell, E is occurring two times, L is occurring two times, but B is occurring one time. So you can put B in the middle and keep all these ELs around it. And that's how we'll be getting, you know, EL, BLE like this. So there are other ways also. We can put, B in the middle of AN and NA like here and keep ELE like, that the way it is. Keep it as it is. Okay. And now if you see this Annalena plus B, so this is also one possible palindrome with this, you know, uh, Annabelle. Okay. So these are the different uh, palindromes possible with the given input string S. Okay. Now, the other thing is, uh, see, the second example is LeetCode, and we have to create the string is LeetCode, and we have to create three palindrome strings. So E is occurring two times, but other characters are, L, T, C, O, D, E. These are all occurring one time. So even if we use double E to create, one palindrome, but others, there is no match for L, T, C, O, D, E. There is all L occurs only one time, T occurs only one time, C occurs only one time, O occurs only one time, D occurs only one time, E occurs only one time. So even if we have one palindrome with EE, the other characters are occurring only one time. So no palindrome is possible here. Okay. And see, why? So see, if we use EE here, let me, go into this example. Okay. So we have lead. This is the example we have. So we can keep this EE as one palindrome, but then we have, we have L, we have T, we have C, we have O, we have D, we have E. So one more E. So with this E we can, put in the middle of this like E, 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 or we can put any one of these characters E, L, E. But even after doing this, we are left with TCOD. So T, C, O, D is remaining. So C, T on its own is a palindrome. C on its own is a palindrome. O on its own is a palindrome. D on its own is a palindrome. So, so two palindromes we can have using this EE, and one, we can use all these, one of the remaining characters L, T, C, O, D. So two palindromes we can create easily. Okay, two palindromes we can create easily. Okay, but even after creating two palindromes, we are left with one, this character, four characters, and four characters on its own, they are, palindrome. So any single character itself is, any single character. Let's say C is a character. So C on its own, on itself is a palindrome. Okay, so C, any single character on its own is a palindrome. Any single character on its own is a palindrome. Any single character on its own is a palindrome. Okay. Uh, so that's why LeetCode is not possible. So LeetCode, we have to return false. Okay. And now if we go to the other example, true. So in true, we have T, R, U, and E. So see, this is occurring one time. Okay. So on its own, T is one palindrome, as we already noticed that any single character on its own is a palindrome. Single char, any single char any single char on its own is palindrome. Is palindrome. Please forgive my handwriting. So any single character on its own is a palindrome. So with this, T is one palindrome, R also is one palindrome, U also is one palindrome, and E is also one palindrome. So we are asked to give construct four palindromes by the value. See, K here is 4. So we are asked to return give four palindromes. So it is possible that true can have four palindromes. So that's why we have to return true here. Okay. So with this understanding, let's uh, think more about this problem. So see here, let's take a look at it. Let's have a look at this. So in this, we are given the string S and the K. So let's, first of all, have the length of the string. So S dot length is the length. And then if N is greater than, if N is less than K, if N is less than K, so see, the number of characters itself is less than K. Then there is no way that we can build K palindromes. So we'll have to return false in that case. Not an issue. This is easy. Now, what we need to do to create palindromes is to have a count of frequency of each characters. So we have to have a frequency of each character. So to get the frequency of each character, what we'll do, we'll create this, frequency array. And in this array will be, of length 26. Why only 26? Because only lowercase English letters has to be considered. Okay. And then what we need to do that we can create one char array. Okay. Char array SARR of the S.to char array like this. And then for char C SARR, we will put in the frequency map C minus A like this, and then we'll increment this plus plus. So this will, after this, we have the frequency map. Okay. Now, what what is the frequency map telling us? It is telling us, the count of characters, count of the individual visual characters in the given string S. Count of the individual characters in the given string S. Okay. Count of the individual characters in the given string S. This is what the frequency is giving us. The frequency array is giving us. Now, the count could be even or odd. Okay. Any count could be even or odd. Okay. Any count could be even or odd. So with this, it is possible that, some count could be like, in the form of 2n, and others, or it could be 2n plus 1. So if it is 2n, then it's not an issue, that, we can put the character in a palindrome form. That is not an issue. Why? Because, let's consider, something which is only consisting of A. Yeah, so, we can have this. Let's consider something which only consists of A. Okay. So only consisting of A. So it will be A, and A, and A. So in this, a single A is 1, and then A, A, A is also one palindrome. A is also one palindrome. Okay. A, 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 A is also one palindrome. So all these are palindromes. Okay. And see, this is one palindrome, and this, so we can create 1, 2. So basically we can create 4 palindromes out of this. So this itself is one palindrome, then these two are one palindrome, and then the remaining is also one palindrome. So we can, at most we can create 3 palindromes, not more than this. Okay. So these are the different palindromes that we have. Now, after having these palindromes, what can we do? See, if the count is even, then that is not an issue. Then that is good for us. We'll be able to create as many palindromes as possible. But what if the count is odd? What is the situation if the count is odd? So if a character is odd, it means there is even numbers, 2n numbers plus 1. So there is one occurrence which is not matching. Okay. So if one occurrence of not matching is there, so let's say, you know, we are asked to create 4 palindromes, and we have, 3 non-matching, characters. So this 2n plus 1, so 1 is the non-matching thing. So let's say we have 3 such, odd count things. So let's say these are C, D, and E. Okay. So what we can do, we can other even number counting things we can put on this side, and others can put on this side. Others can put on this side, and others we can put on this side. So like this, we can create, different palindromes with these 3. And one more way, since let's say we are asked to create 4 such palindromes. So some count of even characters we can put on this side, and other remaining count we can put on this side. Like this, we can do the same with the D. Like this, the same thing we can do with the E. Okay. And the remaining thing we can put on the the remaining thing we can put on the, we can create our own even count. And that we can do using this, we can put in this. So in total, we can have four such palindromes. Okay. But what if, this count of odd is equal to k? If it is equal to k, then also it is not a problem. Why? Because then we can, put all these non-matching characters k times and then arrange other characters on both sides, because there is all others are even count. So we can easily be able to arrange the other characters on both sides of the non-matching characters. But what if that is greater than, k? If it is greater than k, then only k palindromes, we cannot create. In that case, we'll have to return false. So how can we, uh, do this? So in that case, what we'll have to do, we'll have to, first of all, we have to, have a count variable. Count is equal to 0 for, okay, if break of I and 1. Like this, we'll have to increment the count. Okay. Like this, we'll have to increment the count. Like this, we'll have to increment the count. Okay. So this is going to give us the count of odd number, characters in the given string. So this odd number strings, if this count is greater than k, if this count is, less than or equal to k, then no problem. But as soon as it is greater than k, then we cannot create, that many things. Otherwise, in all other cases, because we'll be able to arrange, see, the non-matching characters are equal to k or less than k, and rest all are even occurrences. Then we can be able to arrange the even occurrences on both the sides of the given non-matching characters. Or we can create one more palindrome if it is required, then we can create one more palindrome with the even count. So in all other cases, we'll have to return true. Okay. And then we can just, leave this and let's just run this. Perfect. And then let's submit it. So this is a very easy problem. If there is any doubt, please post it in the, or we can, count, and here only we can, if count is greater than a, return false. Okay, let me leave this. Perfect. So if there is any doubt, please, post it in the comments. With this, I'm thanking you. Thanks a lot. Best wishes. Happy coding.